Hey, what's up you guys? Thank you for joining me again. Now in this video, we are going to be covering the first chapter of Form 5 at Maths, which is circular measure. So without further ado, let us get started. So as usual, before we start with the questions, let us go through some of the examples or the notes that you have to know before you start with the examples, okay? So there are 4 things that you have to know for this chapter. The first thing is conversion. You want to convert between radian and degree. What is radian and degree? So I'm sure you all learned before angle, right? So angle, you have different degrees. So for example, this is 30 degree, let's say. Okay, so this is 30 degree, but there is another form of expressing degree, which is called radian. Okay, so radian is another form of expressing angle. Okay, so it's similar as length. Length, you have cm, you have mm, you have km, right? You have meter. All of these are different units of length. So same thing for angle. You have degree and you also have radian. So how do you convert between degree and radian? So radian is usually expressed in the form of pi. Okay, so how we usually do is, we know that 360 degree is equivalent to 2 pi. Okay, so this is in terms of degree, this is in terms of radian. Okay, so you usually write there pi, 2 pi rad. Rad means radian. Okay, short form for radian. So what about 180 degree? So 180 degree means half of this, right? So it's half means it's going to be pi. So pi can be, some people might use 22/7, some people might use 3.142, some of you all might even use the calculator, the recurring number. You can also use either one, okay? Unless the question state which one you're supposed to use, okay? Other than that, you can just, it's up to you. It's your choice. And then what about 90 degree? If it's 90 degree, it's pi over 2, right? It's another half of this. So pi over 2. And if let's say I want 45 degree, it becomes pi over 4. So basically these are the basics that you have to know, okay? But what if you get some funny angle, like for example 60 degree or 60.5 degree? How are you going to convert? So how you convert is, if let's say you want to convert from radian to degree, or maybe I do degree to radian first, okay? It's the most common one. Degree to radian, you have to, this one is in terms of degree, right? So let's say it's 60 degree, for example. So degree, you want to convert to radian, you take 60 times pi over 180. Pi over 180. This is to convert from degree to radian. If you want to convert from radian to degree, you just flip the fraction here. Okay, this fraction here, just flip this. So you times 180 over pi. Okay, times 180 over pi. So this is basically how you convert between radian and degree. Okay, one is times 180 over pi, the other one is times pi over 180. So you just have to decide which one you want to convert from. The second thing you have to know is finding for arc length. Arc length. So this usually we express this as S lah. Okay. So what is arc length? Let's say you have a circle. Okay, you have a circle, and you want to calculate the arc length of a circle. So let's say a full circle, right? This is what we call as circumference. Okay, circumference. But what if you just want to find one of the sector only? Let's say I don't want to find the circumference, I just want to find here, this sector here. Okay, you want to find the length, that means this arc length. Okay, arc means basically the one small part of the circumference is called arc. Okay, so you want to find this part. So this is not area, by the way. This is not area. Maybe I colored wrongly. This is not area. We are looking for the arc length. So arc length, the equation is S equals to R theta. What is theta? Theta is the angle here. r is the radius. Okay, and this theta here you have to use in the form of radian. Okay, you must use the angle you use must be in radian form. You cannot use degree. Okay, if you use degree you get a different answer. So this is the formula for arc length, S equals to r theta. What about the third point? The third point you have to know is area of sector. Area of sector. So area of sector, see the previous one we learned about arc length. Now what if you want to find the entire area? If you want to find the entire area, the formula is 1 over 2 r square theta. Okay, same thing, the theta here should be radian. The unit must be radian. Okay, so what is theta? Theta is the angle here, and then the r is the radius. Okay, the last one you have to know is number 4. This thing is called area of segment. Oh, by the way guys, this formula is given to you. This formula is also given to you. This formula here, which I'm about to show you, the area of segment, this one you have to memorize because it's not given to you. Okay, so area of segment, what's the formula? Area, by the way, what is segment? Segment is like this. Imagine you got a sector here. This is a sector. The segment is when you draw a line between this point and this point. Okay, key thing, it has to be from this point to this point. Draw a line here. This thing, this place here is called the segment. Okay, this thing is called the segment. Please take note, the segment is between this corner to this corner. If let's say the question draw like this, and then they ask the shade here, this is not a segment because it has to be from one of the corner to the other corner. Okay, so this is not a segment. If it drawn like this, okay, then this is a segment. Okay, so how do you find the area of this segment? There are two ways you can do. The first is you can use your manual way, which is you find the whole thing, the total area minus the triangle. Okay, minus the triangle. That's one way you can do. The second way you can do is you can, sorry, my mouse suddenly not moving. Okay, yeah, the second way you can do is using this formula that I'm going to show you, is by taking 1 over 2 r square theta minus sine theta. Okay, so what is theta? Like I said, is the angle, and then r is of course the radius. Now, key thing you have to understand is this pi here is using in the form of radian, but this theta here is used in the form of degree. Okay, make sure you take note of this. Okay, whenever there is sine, cos, tangent, anything to do with trigo, you cannot use radian. Why? Because you get a different answer. Okay, so if you don't believe, right, you can try this. Just try this. Take one of these, okay, or you take 45 degree for example. Take 45 degree and you can try. If you type sine 45 and you type sine pi over 4, do you get the same answer? Answer is no. You won't get the same answer, and the correct answer is going to be this. Okay, because whenever you are finding for using sine, cos, tangent, trigo, you have to use in degree form. Okay, so if 45 degree, please use 45 degree. Don't use pi over 4. You'll get a wrong answer. Okay, so remember, sine, cos, tangent, please use degree form. But if it's not sine, cos, tangent, you can use radian. Okay, so in this case, remember, this one is in radian, this one is in degree. Okay, so yeah, that's about it. These are the 4 things that you have to know to understand this chapter. And yeah, that's all. So let us go straight to the examples. Alright, so before we start off with the difficult questions, let us start with the easy one first. Okay, so in this case, convert each of the following angles into degree. So now you see they gave you the pi, right? So you cannot use 22 over 7 and you cannot use the calculator one. You have to use 3.142. Okay, if it's stated to you, please use what they have given. So in this case, you want to convert from radian to degree. So what do you use? You have to times 180 over pi. Okay, so in this case, first one, question A, pi over 8 times 180 over pi. So actually you can just cut this. In the end you should get 22.5 degree. Okay, next, question B, 1.04 radian, you want to convert, you times 180 divide by pi. So your answer should be 59.58 degree. Okay, you can leave your answer like this in decimal form. Okay, but some people, they like to use you can convert to degree, minute and second. Okay, if you don't know that, don't worry. Okay, just use as it is. But if you know, you want to explore that, in your calculator you see one of the button is like this one. Okay, but of course depending what calculator you use lah, but most likely going to be this button. Okay, it's below the square root button. Okay, if you're using a different one and it's somewhere else, you just look for this. Okay, and this is the button. So this one is you're converting the degree into degree, minute and seconds. Okay, so if you convert that, your answer should be 59 degree 35 seconds 35 minutes. Okay, so this is your answer. But if you're not using this, even this is good enough. Okay, right, next. In each of the following diagram, POQ is a sector of a circle with center O. Convert each of the angle POQ into radian. So this one is converting from angle degree to radian. So how do you convert? You multiply pi over 180. Why? Because you're converting to radian. I told you before, radian means in the form of pi, right? So that's why you always multiply by the pi first. Okay, in case you cannot remember, that's how I remember. Okay, so now first question, A, 150.5 degree. If you want to convert to radian, you must multiply by pi over 180. Answer is okay, just key in your calculator. Okay, you get the answer. Question B, 220 degree. Multiply by pi over 180. You will get 3.8402 radian. Okay, so these are your answers. Okay, alright, next. Okay, now you're getting a little bit more challenging. Okay, but no worries, you can do it, don't worry. So the diagram on the right shows a sector with, okay, so they gave you a sector with center O and radius 7. Okay, given the arc length is 14 cm, find the, first thing they want to find is the angle, and they want in degree. They want in degree, so take note of that. Question A, they gave you the arc length, right? So what's the formula for arc length? S equals to r theta. Okay, so what is S? S is 14, radius is 7, theta, you're looking for theta. Okay, you don't know what's that. So theta, the angle is going to be 14 over 7, which is equals to 2 radian. Okay, so 2 radian, you have to convert to what? Degree, right? Because they asked for degree. So please take note of that. So 2 degree, how to convert to radian? You take 2 times, you want to convert to degree, right? So 180 divided by pi. So your answer should be 114.58. Okay, in degree form, or you can use the, in terms of degree, minute and second, is going to be 114 degree 35 seconds minutes. Okay, this answer is given to you in your book lah. Okay, if you're using your textbook, this is the answer. Okay, but other than that, you can just use in decimal form, it's fine. Alright, question B, the perimeter of the shaded segment. Okay, they want to find the perimeter of this Okay, not the area, perimeter. So you already know this part. Now all you left is here. So how do you find that? So basically, there are many ways you can do, but I find the easiest way is, of course, you draw your triangle first. Okay, here is 7 cm. What you can do is you can draw a triangle. Right, here's a 90 degree. Okay, so you know that this angle is going to be half of the theta that you found. Okay, this angle here is going to be half of the theta that you found. And then you can use trigo to find this length. And then you times 2, you'll get the full length. So never mind, let us do this together, okay? So what you can do is, this one is what? Opposite, this will be opposite, right? Opposite and hypotenuse, so you can use sine. So sine, so the angle here is what? The angle here you are looking for is half of this angle, right? Half of that. So it's going to be 114.58 divided by 2, okay? Sine the angle equals to opposite, which you are looking for, over hypotenuse, which is 7. Okay, so you shift, you will get your opposite angle is going to be equal to 5.8898. This is in cm. Okay, so if you want to find the perimeter, how do you find the perimeter? Perimeter is equals to 14 cm plus 2 times 5.8898. Okay, so if I draw it like this, you're taking this part plus this part and then plus 14. Okay, so your final answer should be 25.7796 cm. The diagram shows the chain linking the front and back cranks of a bicycle. It is given that the circumference of the front and back cranks are 50. Okay, so which is the front and which is the back? So 50.8 should be the bigger one. So here's the front. Okay, and then the back should be 30.5 cm and the front is 50.8. Okay, calculate the length of the bicycle chain. So since they gave you the circumference, you can find out the radius. Okay, because if you want to find perimeter, here you already have the perimeter, these two. Now you need to find this part, this one and this one. Okay, so you know you can use S equals to R theta. Okay, theta is given to you there, 160 and 185. Okay, but of course you have to change to radian lah. But now what is left is your radian, your radius, sorry. So you want to find the radius. So the only way to find the radius is by using the circumference that they gave you. Okay, so how do you solve that? So you know that circumference is the total angle for circumference is what? 360 is what? 2 pi, right? 2 pi radian, correct? So we're going to use this. Okay, so S equals to, so let's take the front first. This is the front. Maybe I use the back lah. Okay, follow in order. So back, the back crank, and also the front. Okay, so the back, you know that S equals to R theta. So what is S? The circumference is 30.5 equals to radius. You are looking for radius. I put here RB, the back, times the 360. 360 is what? 2 pi, right? So you're gonna find RB is equivalent to 30.5 divided by 2 pi. So you should get 15.25 over pi. Okay, I'm just going to leave it in terms of pi so that I don't disturb my final answer. Okay, I'll leave it as it is first. Next, you want to find the front. So front is going to be the same thing. 50.8 equivalent to RF, because the front, multiplied by 2 pi. So RF is equal to 50.8 divided by 2 pi. So your answer is 25.4 over pi. Okay, you will see why I leave it in terms of pi. Okay, you'll see why later. So now, you already found your radius. Now you want to find this part. the arc length at this particular arc. Okay, you want to find this arc length. So to find the first one, let's say we do the back first. Okay, so the back 160, you must convert it to radian. 160 convert to radian is times pi over 180. Okay, and then the 185 you also have to convert. Okay, you know what, I'm not going to convert it there, I'm just going to do all one shot. Okay, so you want to find the arc length, right? So S of the back one, okay, equals to radius is 15.25 over pi times the angle. So the angle is what? 160 times pi over 180. So what you notice is that, you see here got pi, here got pi, I can cut, right? It makes it very easy. So I try not to calculate everything at once. Okay, I try to make it in the form of pi first, and then you see where you can cut. Okay, so in this case, when you use your calculator, you should get your answer 13.5556 cm. Okay, this is the arc for the back wheel, back crank. And then you have the front. So the arc for front is going to be R is 25.4 over pi multiplied by, so it's 185 times pi over 180. So same thing, you see the pi here, you can cut. So in the end, you should get your answer 26.1056 cm. Okay, so they're asking for what? Calculate the length of the bicycle wheel, right? So it's basically asking for perimeter. Okay, length of bicycle chain, okay, is the perimeter, equals to what? 25 plus 25 plus 13.5556 plus 26.1056. So you get your final answer 89.6612 cm. Okay, so this is your answer. Right, next. Area of sector of a circle. Okay, now same thing. They gave you this circle here with the sector. The radius is 3 cm. And then they say the minor arc length. So this is the minor arc length. Is 5 cm. Now they ask you first question, they want you to find MON. So MON is here. Okay, they want you to find the angle, but in the form of degree. Okay, so same thing, this one we did before, previous question. They give you the arc length, so you just use the formula S equals to R theta. So S is what? The arc length is 5 equals to R is 3 theta. So what is theta? Theta equals to 5 over 3. Okay, you can leave it like this, or you can write in decimal form. So decimal form would be 1.6667, but I try not to leave it in decimal form first, because whenever you round off the number, right, your final answer will change. So I try not to do that. Okay, so but now they want in degree, right? So you have to change it to degree first. So you times 180 over pi. So you will get, your answer is 95.48 degree. Okay, so you're going to need both of this later. Okay, why? Because you see the second question, what they're asking, area of shaded segment. So this part, right, this is the segment. So shaded segment is, I told you all the formula before. Question B, area of segment is what? Area of segment is equals to 1 over 2 r square theta minus sine theta. And this one is in radian, don't forget, this one is in degree. Okay, please don't mix up. So 1 over 2, what is your r radius is 3, right? So 3 square. And then let's see, pi is your theta is in radian. So radian you already found here, right? In terms of radian, 5 over 3 minus sine, what's the angle there? In degree, right? So this is your in degree form. So 95.48. Okay, so you just key this into your calculator, you'll get your answer straight away, which is 3.0206 cm square. Okay, yeah, that's about it. So it's quite straightforward, right? Once you know the formula, it's quite easy. Okay, let's go to more challenging question. So now this one, the diagram on the right shows a cross section of a water pipe with internal radius. Okay, so they specifically said internal radius, so that means the radius is from the center all the way to here, this part. Okay, it's not touching it's not the outside part here, it's not including that, it's just the internal area. So it's 12 cm, and then they ask you to find the height, so the h here. Okay, and the horizontal width is here. Okay, 18. So the first question, they ask you to find the h. Okay, so how do you find the h? So the first thing I want you to understand is, if you have a sector like this, okay, how am I supposed to find this? You take the radius, because you know that since this is the radius, right? So that means from here to the whole thing down here, the whole length is radius, correct? So if I want to find the height, I must take the whole radius minus this part. Let's say this x, okay? This part. From here to here. I don't know if you can see or not. Right? I take the whole length, which is the radius, minus this part. I'll get the height. Correct? So that's what we're going to do. We are going to... Sorry, my drawing is pretty bad. But that's what we're going to do. We are going to find we already know the radius. Now all we have to know is the height of that triangle. So let me redraw this so that you can see clearly. So you want to find this height. So let's assume this height is let's put it as x. Okay. So the whole length between EF is 18, right? So if I cut into half, it's going to be 9 here. Here going to be 9. Correct? 9 plus 9, 18. And then the radius is 12. So how do we find x? Okay, I wrote x as the height of the triangle. Okay, so x is Pythagoras theorem. Okay, so x equals to square root 12 square minus 9 square. You should get 3 cert 7. Okay, so I'm going to leave it in this. Like I said, I don't want to round off the number so quickly, so I'm going to use 3 cert 7. Okay, cm. Now you want to find the height, right? Height is here. So the height is equivalent to the radius, which is 12 minus 3 cert 7. So your answer is going to be 4.0627 cm. Okay, this is the height. Next question. They ask you to calculate cross-section area covered by water. So basically they're asking for area of the segment, correct? You see where is the water in the diagram? This part, right? So it's the area of the segment. So how do you find the area of segment? The formula, correct? Question B. Formula is what? Area of segment 1/2 r square theta minus sine theta. Okay, the first theta is in terms of radian, the second theta is in terms of degree. Okay, so now how are we going to find the angle? So we know that we are looking for this angle, right? This whole angle is what? The whole angle is theta. But now what I can do is I can use this triangle to find this, right? And at times 2, I will get 2 sides lah. Correct? So I'm basically using the triangle. So I can use what? SOHCAHTOA. Right? So if this whole thing is if this whole thing is theta, the half here is called theta over 2. And here also theta over 2. Correct? So let me redraw this. So you got a triangle now. Here is 12. Here is 9. Here is theta over 2. okay, because the whole thing is theta, so the half is only theta over 2. Okay, so now we can use SOHCAHTOA. So in this case, what are we going to use? Opposite and hypotenuse. So it's sine, right? So sine theta over 2 equals to opposite is 9 over 12. Okay, so you can shift this, you should get your theta is equivalent to 97.18 degree. So this is in degree, but you also need in terms of radian, so you times pi over 180. So you should get your answer 1.6963 radian. Okay, so one in terms of degree, one in terms of radian. Now you can find your area of segment. 1 over 2 times r, what's the radius? Radius is 12 square, multiply by theta. This first theta is in terms of radian, right? So 1.6963 minus sine, this is in terms of degree, so 97.18. okay, key this into your calculator, you should get your answer straight away. 50.7019 cm square. Okay, so this is how you solve much challenging questions. So I hope you guys understand this. Okay, now let's see more examples. So the diagram on the right shows two discs with radii 11 cm and 7 cm touching each other at point R. Okay, the discs are on a straight line PDCQ. Calculate BAD in degree. Okay, so let me redraw this. You got basically like a trapezium, right? So here 90 degree, here 90 degree, here is 7 cm, here total is 11 cm. Okay, so now they want you to find BAD. Where is BAD? Here is A, here is B, here is D, here is C. So BAD should be the angle here. Okay, so how, in what way can you find that? So I want you all to understand this. There's a trick. Usually, right, when there is a 90 degree, there is always a right angle. There is always a right angle. Okay, so where is your right angle in this diagram? The right angle is here. You can draw a line parallel to the bottom line here. Okay, so that means here is also 90 degree. So now you have your right angle triangle. Okay, you have your right angle triangle. So if this is a right angle triangle, you know this is 7 cm because it's going to be the same as this, right? So what is the length here? 11 minus 7, so here is 4. Okay, you want to find this angle, you know this is 4. What other data can you get? You know this length. You should know this length. How to know? Because you notice that in this diagram they are the radius, correct? This radius here is 11 and then this radius here is 7. So that means this length AB is actually 11 plus 7, which is 18. Okay, so now you have this length, you have this, you have this, so you can use your SOHCAHTOA, okay, to find the angle BAD. So question A, you want to find angle BAD. So what are you going to use? You're going to use adjacent and hypotenuse, so it's cos. Okay, so cos angle BAD equals to adjacent is 4, hypotenuse is 18. Okay, so what's your angle BAD? Should be equals to 77.16 degree. Okay, so they want in degree, right? So this is your answer. Question B. Subsequently find the shaded area. So shaded area is where? Actually, if you didn't notice, this is the shaded area. Okay, this is the shaded area. So how are you going to find this area? The only way you can find this area, right, is by using the whole trapezium here. Find the total area minus this area, the area of this sector, and minus the area of this sector. Okay, that's it. When you can do that, you get your answer, shaded area. So area of trapezium you can find, because you know the formula is what? 1 over 2, the two parallel sides, you add them up, a plus b times the height. Okay, so the height is here, but you don't know what is the height, correct? So how are you going to find the height? The height is going to be, you can use back this triangle, right? You know this and you know this. So to find the length CD, you just have to do Pythagoras theorem. Okay, to find, okay, let's do it together. So question B, okay, I'm just gonna draw here so that you got space. Question B. So let us first find the height here. Okay, so let's assume this is the height. So height is equals to 18 square minus 4 square, and then square root. Okay, so your answer should be 2 cert 77. Okay, I'm going to leave it in this form. I don't want to round off first. If I write in decimal, I have to round off, so I don't want that to do that so early in the process. So this is 2 cert 77 cm. So you can now find the area of the entire trapezium. So now you have to find area of the sector. Yeah, so this sector you can find because you already know this first sector here, this one you can find because you know the radius, because the formula is what? 1 over 2 r square theta, right? So theta is the angle, radius, r is radius, so you already know the radius and you know the theta, the angle, which you already found here, 77.16, but you have to change to radian later. The second sector you have to find is this one, right? But this one is a bit hard because first thing is you don't know, oh, actually you already know the radius, which is 7 cm, but you don't know the angle, right? You don't know what's the theta. So now you have to find the theta first. So how are you going to find the theta? How are you going to find? So the only way you can find is, actually maybe there are other ways lah, but the way that I can think of is, we can take, you know that a full trapezium, what's the total angle? 360, right? Here is 90, here is 90, here you already found is 77.16. So now you can find this, right? Correct? So you can just straight away do that to find the angle. So we are going to do that, okay? So let me just erase this. Okay. Alright, so let's find angle ABC. Okay, so that angle is going to be equals to 360 minus 90 minus 90 minus 77.16. So that angle is equals to 102.84 degree. Okay, so this angle, of course, we have to change to radian because we want to use to solve the area. Okay, so now we're going to straight away do that. Area of shaded region. Okay, area of shaded region is equals to, you take the whole area, right? Area of the trapezium, so 1 over 2 times a plus b. What is a and what is b? A is 7, the two parallel sides. Please don't take this and this. No, must be the parallel sides. So the parallel sides are 7 and the other side is 11. So 7 plus 11 multiply by height is what? You already calculated, 2 cert 77. Okay, minus area of the first sector there, which is 1 over 2 r square is, r is 11 square, theta is what? Theta is BAD, right? So 77.16. Don't forget to change to radian, so pi over 180. And then minus the second sector, 1 over 2 r square, r is 7 square, and then the angle is 102.84, so 102.84 times pi over 180. Okay, so use your calculator, you should get 18 cert 77 here, minus 81.4857 minus 43.9807. So your final answer should be 32.4830 cm square. Okay, so that's how you solve this kind of question. Right? Next, the diagram on the right shows a moon-shaped kite whose line of symmetry is OS. Okay, for this question, right, I really need you all to see closely because it's quite tricky. Okay, so just look at this. So AQB, where is AQB? This is AQB, right? AQB is arc of a sector from a circle with center also. Sorry, so here is a sector. Okay, I need you all to take note, because if you don't see closely which arc it belongs to, and you will in the end, right, you don't know which radius to use. Okay, so this question is a bit messy lah, so I need you all to take note of that. So now in this case, this arc, what is the radius? The radius is 20. The center is O. Okay, so take note of that. The second one they say is what? APBR. Where is APBR? APBR is a what? Semicircle. So that means for this arc here, if you want to find this arc, you need the radius is 16. Okay, please don't use the wrong radius. If you use 20, you get the wrong answer. So okay, so that's done. Next, they tell you radius 16. TRU is an arc from circle with center S. So this one is quite straightforward. This arc here belongs to this sector. Okay, and then the radius is 12, and then given that arc length of TRU, so this arc length here is 21 cm. Calculate AOB and TSU. Where is AOB? AOB is here. TSU is here. So TSU is actually quite easy, right? TSU is quite easy. Okay, let's find TSU first. So TSU, you can just use the formula. S equals to R theta. So the S is 21, R is 12, theta is theta lah. So theta equals to 21 over 12, which is 7 over 4. So right here, 7 over 4. Okay, I try not to simplify first, so that in the end later, wait, this one I think you can do. Wait, this one you can simplify to 1.758. So I'm just gonna write 1.75. 1.75 radian. If it's a recurring decimal, I try not to simplify so soon. Okay, because otherwise the final answer will be very far from the actual answer. So now this is TSU, or angle TSU. Now you want to find angle AOB. So angle AOB, let's say this is theta. Okay, so this, you know, this is 20, this is 16, so you can form your right angle here, right? So this small angle here is theta over 2. Okay, because it's, you cut into half, so theta over 2 is, that's half of that angle. So we're going to use opposite. This angle here is this length is opposite this hypotenuse, right? So opposite hypotenuse is sine. So sine pi, okay, wait, sine theta over 2. Okay, I cannot use theta because it will overlap with this previous question here, this one. So I'm not going to use theta. Let's just use angle AOB over 2. Okay, sine of this is equals to opposite, which is 16, over adjacent. So you shift one by one, you should get angle AOB equals to 106.26 degree. Make sure you change to radian, because they ask for radian, times pi over 180. You will get 1.8548 radian. Okay, so this is the two angles that you're looking for. Okay, next they ask for perimeter. So where's the perimeter? Perimeter here you already know. 21. Here you also know 12 and 12. So all you have to find is this and this. Okay, when you can find the two, then you can find the perimeter. So let's find question B. Let's first find ARB. So ARB is equals to, so we use this semicircle. Please, that's why I say you have to know which radius to use. Okay, so since it's a semicircle, it's going to be r theta, right? R is 16. Theta is, the angle is half a circle. So I told you before, 180 is equals to pi, right? In radian form, right? So this is pi. So you get 16 pi. I'm just going to write 16 pi first, okay? cm. After that, you're going to find for AQB. AQB is using the sector. Okay, so the sector, the radius is 20. Theta is, you found the AOB, right? So it's this one. So it's going to be 1.8548. So you get, your answer is 37.0966 cm. So you want to find perimeter, right? So I'm going to write here, perimeter equals to 37.0966 plus 16 pi plus 12 plus 12 plus 21. Okay, your final answer should be 132.3686 cm. So now we have to find for the last question, which is area. So how do you find area? So area here is a bit complicated. See, okay, let me erase this because I don't have enough space. Okay, erase this and this one. Okay, now we want to find for area. This area is very easy to find, right? Because you just straight away use the formula. However, if you want to find this other shape here, this moon shape, it's a bit hard because why? First thing is there is no formula for this. Second thing is you have basically two shapes involved. First is a semicircle and a sector. So take note, how are we going to do this? We are first going to take the semicircle. Okay, we use a different color. We take the semicircle. Now the semicircle, you have to minus this, correct? To find this area. So how do you find the area of that segment? You can use the formula, area of segment formula, but in this case I'm not going to do that. What I'm going to do is I'm going to take the entire area of the sector, minus this triangle, because we know it's a triangle, right? So I'm just going to minus that. Also can, okay, you can use that, or you can use the formula of the segment, area of segment formula. Okay, so I'm going to use the way that I just mentioned, minus a triangle. So let's do this together. So area, question C, area is equals to, let's find this first, this one. So it's very straightforward. 1 over 2 r square. What is r? 12 square. Theta is, where is TSU? Okay, here, 1.75 plus, okay, now here is where it gets tricky. So you want to first find the semicircle first, right? So semicircle is 1 over 2 r square. What is r? R is 16 square. Theta, okay, I don't know whether you can see or not because I color. Okay, so r, the radius is 16, and then theta is what? Half a circle is pi. Okay, minus, so the semicircle must minus the sector, correct? But the sector is what? How to find the sector? The sector, you have minus 1 over 2 r is 20, r square, theta, where is theta, is 1.8548 minus the triangle. So triangle is 1 over 2 times base. Base is 16 plus 16 is 32. Okay, this is the base. Okay, but what about the height? Okay, so the height here is OP. How to find OP? You can use this triangle. Okay, so OP is equals to what? 20 square minus 16 square. Okay, Pythagoras theorem. So you should get 12. Okay, so that is 12 cm. So 1 over 2 times 32 times height is 12. Then you close all the bracket. Okay, I know it can be a bit confusing, and I'm sorry I'm writing it this way because it's so hard to see. But as long as you understand what I'm trying to do, okay? So in the end, you should get, so this part here you should get, this is the area of TRUS, correct? This sector here. So that area here should be 126 plus, so the area of the semicircle, area of semicircle, what's the semicircle? APBR, yeah. APBR should be 402.176, okay, minus what? Should be the sector. The sector should be, what is the sector again? AOBQ, right? AOBQ is 370.96 minus the triangle, which is 192. Okay, so in the end, you can use your calculator. You should get your answer is 349.216 cm square. Oh my god, I hope it's not confusing. Okay, I'm gonna repeat this, okay, because I don't want you all to get confused. Let me erase all this. Okay, so basically what is happening is you're going to find this area, which is this part, okay, area of the TRUS, okay, plus area of the semicircle. Semicircle is APBR, okay, minus, you want to find the sector. So how to you want to find the segment. So how to find the segment? The segment is, you have to first find the sector minus the triangle up here. Okay, so the sector is AOBQ minus the triangle AOBP lah, okay. So basically this is what I'm doing here, okay. So the TRUS, okay, this sector is this one, and then I plus APBR, which is the semicircle, so this is APBR, minus this one is to find the area of segment, which is what I did here, this part. Okay, so I hope you find this more able to understand, okay. So I hope I didn't confuse you guys. Alright, let's see the next question. We have 2 more questions and we're done with the chapter. So let's see this. In the diagram on the right are 3 identical 20-cent coins with the same radii and touching each other. If the blue colored region has an area of, okay, so they give you the area of the colored region, find the radius of each coin. Okay, so they give you nothing, no data except the area of the colored region. So how are you going to find? So if you notice, it's a tricky question, but what you can do is, you see, there's a center here, correct? There's a center here for each of the coin. What you can do is, you can connect the radius. Here is the radius for this coin, and here's the radius for this coin. Here's the radius for this coin, and here's the radius for this coin. The radius here and the radius here. Okay, so here is R, here is R, here's R, here's R, here's R, here's R, because all same radius, right? Same coin, same radius. So in other words, you have a triangle. Okay, you have a triangle. Here is 2r, here is 2r, here is 2r. Okay, so since they are all same length, all 2r, right? So it's an equilateral triangle. And for an equilateral triangle, what are the properties? So the property is all three angles are the same, which is 60 degree. Okay, 180 divided by 3. So you get 60 degree each of the angle. So now we can use this info to solve. Okay, so what is the formula? To find the radius, right? We have to form an equation using this. Okay, because only this is given to you. So how to find the area of colored region? How do you find that area? The area of the colored region is equal to area of the triangle minus 3 times of the area of sector. Okay, so in other words, you just have to find each sector. Okay, if you just find one sector times 3, you'll get 3 sectors. So the whole area of triangle minus the 3 sectors, you should get the area of the colored region. So let's form the equation. Okay, so colored region is given to you 12.842. Area of triangle, so you can use 1/2 times base times height, but in this case the easier one would be we learned in form 4, area of triangle 1/2 AB sine C. Okay, remember I think I told you all chopstick, right? Like chopstick. So AB sine C, so the two length, if let's say I'm using this angle, right? So the two length must be this two length. Okay, if I'm using this angle, the two length should be this two length. Okay, so 1/2 AB is 2r times 2r sine C, so it's 60 degree. So make sure you use 60 degree because this one is sine cos tangent. Remember I said sine cos tangent you have to use in degree. Okay, if it's the normal formula for this chapter, then you use in radian. So in this case, this is the formula, minus 3 times area of the sector, so 1/2 times r is what? The radius is each of this is r, right? So it's r square times the angle is 60 degrees, so 60, please change it to radian, so pi over 180. Okay, so you will get 12.842 equals to sert 3 r square minus pi over 2 r square, and then you rearrange this, you should get r square equals to 79.7388. okay, so in the end your r should be equals to 8.9297. this is what mm, yeah. Okay, so the actual answer that was given is actually 8.931, so it's actually pretty close, so it's acceptable. Okay, so it doesn't this chapter, right, you won't get a accurate, like exact answer, because there are many decimal places involved. Okay, some people might just take 3 decimal place, and then the pi, some people might use 3.142, some might use 22/7. In this case I'm just using 3.142. okay, some people might use the one in the calculator. Okay, so you will in the end will get different answers. Okay, yeah, so this is how you solve this question. Don't be frightened by the question. Okay, try to figure out how can you solve this, because only one value is given, so you must try to figure out how you can solve this. Okay, all right, one last question, let's go. The diagram on the right shows the logo of an ice cream company. The logo is made up of 3 identical sectors. Okay, so these are the sectors here, the 3 sectors. Okay, from the center, and radius of 30 cm. So all these are the radius, 30 cm, 30 cm, because all identical, right? And then it's given that all these angles are 60. So here 60, here 60, 60. Calculate. Okay, question A. They ask you to calculate arc length of AB. Where is AB? AB is here. So what's the formula? S equals to R theta. So I'm just going to write AB, arc AB equals to, radius is 30, theta is 60. Please change it to radian. Okay, so you should get your answer 31.42 cm. Okay, that's the first one. Second, okay, I need to cram a bit because I don't think we got space here, but never mind. Second one is area of COD. Where is COD? COD is here. They're asking for sector, right? So you have to include the segment as well. So this whole thing. Okay, so we just use the formula of sector. So area of sector COD is equals to 1 over 2 r square. What is r? 30 square, and then theta is 60 times pi over 180. So your answer should be 150 pi, also equals to 471.3 cm square. Okay, so if you get anywhere close to 471.15 is acceptable. Okay, that's the actual answer. Next, you want to find for perimeter of segment EF. Where is EF? Okay, EF is here. So this is the perimeter. So the arc length you already found, right? Arc length is this, because it's identical shape. So here also is 31.42, yes. So now you want to find the EF, this straight line here. How to find that? So what you can do is, you can form your you can see your triangle, right? Your triangle. Oops, sorry. Okay, so this is EF. So you can form your triangle here. 90 degree. Okay, so what you can do is, here is 60 degree, right? So this one is going to be 30 degree. You know the radius is 30 cm. You want to find here. Okay, so what is that angle there? Let's say this is opposite, right? Opposite. So opposite and hypotenuse. So you can use SOHCAHTOA. So you can use O and H. So sine. So question 3. Sine 30 is equivalent to opposite over 30. So what's your opposite angle? Opposite angle should be equivalent to 15 cm. Okay, so here is 15. So now you need to find 15 and 15. Okay, let me just write here. So this half here is 15. Here is 15. Here also 15. Right? And then you want to find the perimeter. Okay, so perimeter is equivalent to 31.42 plus 15 plus 15. So your final answer is 61.42 cm. Okay, next, area of segment EF. So this one, I already gave you all the formula, right? Just straight away use the formula. No need to think already. So area is equivalent to 1 over 2 r square. What is r? 30 square times theta is what? Theta is 60. So you have to change to radian. 60 times pi over 180 minus sine 60. Okay, because this must be in radian. This one must be in degree. So you should get, straight away you can get your answer, 81.5886. Okay, now like I said, it doesn't have to be 100% accurate, okay, as long as it's close to the answer, because you might use different value of pi. okay, or you might use 3 decimal place or 2 decimal place, okay. So in the end, you may not get the exact same answer, but if it's close, it's acceptable. Okay, last 2 question. The logo is casted in cement if the thickness is uniform and is 5 cm. So the thickness now is 5 cm. Okay, find the amount of cement needed to make the logo. So to do that, you must first find the total area and then times the thickness. Okay, the total area, that means in 2D form, of the logo times the thickness. So what is the total area? Actually, just straight away find the total volume. So total, they ask for volume, right? Equals to, what's the area? Area of the whole sector, right? So you got COD is this area, one area, right, of the sector. So you take 3 times of that, which is 3 times 471.3, and then you times 5 cm, because that's the thickness. So in the end, you should get 7069.5 cm square. Okay, sorry, cm cube, because it's a volume. Okay, so that's how you find the volume. Last question, question C. What they're asking: if the cost of cement is 50 cents per cm cube, find the total cost. Okay, so they're saying 1 cm cube is 50 cents, right? So how many you have? How much you have? You have 7069.5 cm cube is equivalent to, just multiply lah. Okay, actually I shouldn't write equal, I should just, okay, this one is 7069.5 times 0.50. So your answer should be RM 3534.75. Okay, so this is how you solve this kind of question. It's actually pretty straightforward, right? This question, it looks long, but it's actually very straightforward. Alright guys, so that's all for this video. These are the 4 main things that we have covered in this video. We have covered the whole entire chapter. We have covered radian, arc length, arc of the sector, and we also covered arc of segment, and then some application questions. Alright, so that is all for this video. I hope you find this useful. If you did, don't forget to like, subscribe, and share it with someone who will also find this beneficial. Alright, so until next time, hope to see you on my next video. Alright, take care. Bye bye.